Hello everyone, this is the first video that I'm making on history, and the video is on significant figures. Alright, so let's get to it. First, let's talk about what is a significant figure in chemistry. Okay, so let's say you have, for instance, let me see. Let's say you have 5 brownies. 5 brownies sounds like a something that's believable. You can have 5 brownies, everyone agrees with it. But if I were to say I have 5.25 brownies, then you're gonna be like, wait a minute, 5.25, how sure are you that you have 5.25? Like, how can you possibly be sure? Because for 5 brownies all you have to do is count, but for 5.25 brownies, how do you count that? So when you deal with decimals and uncertainty, we get into a topic in chemistry that deals with significant figures. So first of all, every number that they give you, so if they give you the number 5.25, every number is certain except for the last one. So the 5 and the 2 are certain. Everyone knows that these two are for sure. But this last number right here is uncertain. You don't know if that number was rounded. You're not sure exactly, because what a lot of people tend to do in life is they tend to round numbers. So you're not sure if that number was rounded or not. And that's where the uncertainty comes in. So now I'm going to do a couple of examples. Now that I gave you an introduction to significant figures, I'm going to do some examples so that you can see what I mean. Well, first of all, the first thing you need to know about significant figures is that all non-zero digits are significant. So I'm going to write that down. All non-zero digits are significant. So every number is pretty much significant, every non-zero number. So if I give you the number 1.07, right, which ones are the non-zeros? The number 1 and the number 7 are non-zeros. So then the number 1 and the number 7 are significant. That's rule number 1. All non-zero digits are significant. Rule number 2 says interior zeros are significant. Interior zeros are significant. So let's I'm going to write down the number one more time, 1.07. We already said that the 1 is significant, and we already said the number 7 is significant. But rule number 2 says that the interior zeros are significant. So this 0 right here is an interior 0 because it's between these numbers. So that 0 is significant. Let's go to rule number 3. Rule number 3 says that trailing zeros are significant. Trailing zeros are significant. What are trailing zeros? Okay, trailing zeros, let's say I have 1.07 and I were to add another 0 here in the back. This is a trailing 0. Okay, so zeros after the decimal, zeros after the decimal are significant. This is what's called a trailing 0. So let's go back to this. In this example, the 1, the 0, the 7, and also this 0 are all significant. So this number has a total of 4 significant figures. Okay, so now let's go to the final rule. It says leading zeros are not significant. Leading zeros are not significant. Okay, so leading zeros. What are leading zeros? Let's say I have the number 0.0 0, 2. These zeros, the zeros on the left, are not significant. These leading zeros are not significant. That's what this rule means. So now you know the leading zeros and the trailing zeros, and we're going to do some examples now. Alright, so let's see. The first example that I have here is 58.31. So how many significant figures does this number have? Well, this number has a total of 4 significant figures, 4 sig figs. Okay, so according to rule number 1, every non-zero is significant. So 1, 2, 3, 4. This number has 4 significant figures. These 3, 5, 8, and 3 are certain, and the 1 is an uncertain value. You don't know if that was rounded or not. But the point is they're all significant. Alright, the next example, 0.00250. Okay, this number, we know that the zeros on the left side, so these 3 zeros over here, are not significant, but we do know that the 0 on the right hand side is significant because this is a trailing 0. Okay, remember, trailing zeros are to the right and leading zeros are to the left. So this number has 3 significant figures. Alright, the next example, 2.7 times 10 to the 4th. Okay, this number, now we're getting into scientific notation, and that's a little bit more complicated. So this number actually has 2 significant figures. This one right here, 1, and this one, 2. So that number has 2 significant figures. 2 sig figs. Alright, let's go to the next example. 1 centimeter is equal to 0.01 meter. Okay, this one is a very good number. It's a very good example because this right here is something that's defined, and when you have defined values, you have an unlimited amount of significant figures. This is unlimited because this is a defined value. Okay, next example, 0.500. This one has 3 significant figures. Remember that the zeros on the right are the trailing zeros, and you can count those. So this has 3 significant figures, but you do not count the 0 on the left. Okay, and the last example, 2100. This is perhaps the best example from them all, and the reason is because this number is actually, it's ambiguous. Notice that all the other ones that we've done, they've had a decimal, but this one doesn't. This one doesn't have a decimal. So this one, you can write it like this, 2.1 times 10 to the 3, and if you write it like this, then the number has 2 significant figures, 2 sig figs, if you write it in scientific notation. But if you write the number like this, 2.100 times 10 to the 3, if you write it like this, then the number actually has 4 sig figs. The number has 4 significant figures if you write it like this. So this number, this one is ambiguous. You gotta be careful with this one because you can actually put the decimal here, or you could put the decimal well, yeah, in the same place, but this one has zeros here in the back and this one doesn't. So stay tuned for the next videos, and I hope this helped.